Section 14A, question number 3 on page 346. In this question again we are asked to evaluate the limits that are given. Now in this case we want to look for ways to simplify these expressions before we substitute in the value. Okay? In some of these cases that are in this question, it's not necessarily an issue because we won't get the indeterminate form by substituting the value right into x. However, or into the variable, as we'll see. But the most important way, or the most efficient way, and the proper way to do this is to simplify the expression first. Okay, so here we're asked to find the limit of x squared minus 3x all over x as x approaches 1. Okay, so we're going to continue this limit notation, and then we're going to simplify here. So I see in the numerator I can factor out an x, and then I can cancel out the x over x because x over x as a fraction just equals 1, so those are gone. So then I'm left with the limit of x minus 3 as x approaches 1. Now we substitute in the 1 and get negative 2. So the y value that the function approaches when for this function of x squared minus 3x over x as x approaches 1 is negative 2. Sorry about that. There we go. Moving on to b, we want to find the limit of h squared plus 5h all over h as h approaches 2. So again, we'll do the same thing. We'll simplify the numerator, and we'll get factor out an h. So we got h quantity h plus 5 all over h. The h's cancel, so we're left with the limit of h plus 5 as h approaches 2. Now we substitute in the value of 2 in for h, and we simplify there, and we get 7. So the y value that this function approaches as h approaches 2 is 7. Let's move along here. C, the limit of x minus 1 all over x plus 1 as x approaches 0. Okay, so we'll take a look at this now. As we examine this, we see that there's nothing that we can factor out, there's nothing that we can simplify down, so we can just go ahead and substitute in the values, or the value of x equals 0 in for x in the numerator and the denominator. Those of course don't affect the numerator or denominator at all, and so that gives us a limit of negative 1. So this function approaches the y value of negative 1 as x approaches 0. And now for part D, we see the limit of x over x as x approaches 0. Now in this case, if we were to substitute 0 in for x and x, we would get the indeterminate form of 0 over 0, which doesn't really tell us anything. So again, just like we did for part A and part B, we're going to need to simplify this down first, and we see that x over x, those cancel out, so we're left with a limit of 1 as x approaches 0, and we see that this is just a constant, so the value is 1 anyways. Therefore, the y value that this function approaches as x approaches 0 is 1.